I thought it'll be a great session on a Thursday morning where we do a tech deep dive on OpenTelemetry and talk about what exactly is the standard, how it is changing the way people observe applications and infrastructure, and how you can use it. So pretty much it'll be a little bit of a technical deep dive into OpenTelemetry and the concept of that. And the goal would be that you're able to go back in your organizations, talk about OpenTelemetry, see how you can join in, how you can contribute to OpenTelemetry, and at the end of the day, make world a better place. And I'll tell you why it becomes a better place as we move forward. All right, so let's get started. Again, you are all aware of this slide, so I'll just jump on and talk about some of the key agenda items which we'll go through. So I'll start with observability challenges. It's not unknown that OpenTelemetry was built to solve observability challenges. So it's always good to kind of remind ourselves as to what our industry is going through and what people who are working on observability, whether it's network or whether it's applications, whether it's any kind of infrastructure, go through on a day-to-day basis. And it's not just those personas who are trying to troubleshoot and fix problems, but it's also personas who are trying to make sure that they can control the costs of running observability. So we'll touch upon those. And then we'll talk a little bit about the concept of full stack observability. I'm pretty sure you've heard this term over the last few days, especially when we did announcements, and I believe one of the Toms out of the three talked about how we are bringing together the Cisco and Splunk portfolio together. And I'll touch base a little bit upon that because that gives us the foundation to talk about OpenTelemetry as we move forward. And then we'll touch upon the benefits and look at some of the latest innovations which you can start thinking about as you start thinking about adopting or even contributing to OpenTelemetry. Okay, so let's start with some of the basic stuff. Again, I'll not go into stats and numbers because I think you've already, did you raise your hand for a question? No? Okay, no problem. But yeah, I'll not go into numbers. You've seen a lot of numbers and how many percentage of people say what, so I thought I'll directly be a straight shooter and show you some images. Obviously, there are a lot of tools. I think that has been established over the last 4 days and over the last 40 conferences where people talk about tool sprawl. So I wanted to start with that, and yes, tool sprawl is a problem because of non-standardization of data, and I'll talk about what does that mean in a second. The second big problem is agents everywhere. Now, this is a funny stat, and I'll talk about this stat because this is not from a study, but from a direct conversation with a customer. This is a customer in hospitality industry, and they brokerage thousands of transactions every day by having people booking hotels across the United States through their single site. And this customer has moved 100% onto AWS. And while talking to them, they told us that 45% of their AWS CPU and memory usage is coming from agents. It's not coming from the real business or application, but it's a security agent, or it's an observability agent, or it is a firewall agent, and so on and so forth. And a lot of times, all of these agents are creating duplicate or collecting the same data, sending it to different platforms for different use cases. But the data remains the same. Everybody collects the annotation of what the attribute is, like a name, or collects what is a CPU usage or memory usage on a box, and send it out to different tools. And each of these collection cycles is CPU spent. And they were able to slash down this massive cost by adopting OpenTelemetry because they were able to reduce a number of agents and then go towards a single collector with OpenTelemetry. And I'll tell you why and how it was possible. But maximum cloud bill is because of why you're trying to put agents out there. And if you're able to slash that, you're able to cut down cost by 2/3 in some cases. And the other thing, as you know, we talked about tool sprawl. This is a bigger problem. You might have all the tools in the world. You might have bought observability from Cisco or any other vendor. But the reality is that if you do not stitch the context together, it's hard, and you will have scenes like this in your office. So who have seen scenes like this? I mean, they're not this pathetic, but you understand the frame of mind of that person sitting there. It's crazy, right? And this is repeated again and again and again because you have those problems of multiple tools. You have problems of sending different signals to different tools and having different contexts not matching together. So that is another problem which we want to solve for, and let's see if OpenTelemetry can help and how. And last but not the least, this is my favorite. I know the spelling is wrong because I was using AI to generate some of these images, and that's what it does. But the reality is that if you choose a tool to monitor, let's say you choose a Cisco tool to monitor, and you started creating alerts, sending those alerts to your ServiceNow instance. And now you have an operations team which is running the entire operations day in, day out. It's like a breathing thing, right? Now, if the vendor, let's say it's not Cisco in this case, let's say X, comes to you and says, hey, by the way, this is your bill based on your pay-as-you-go model. And if that bill is a surprise bill for you, what do? You start negotiating, right? Hey, come on, you can't do this to me. Let's just kind of negotiate. And you can negotiate only to the terms of if the other person wants to negotiate. But what you cannot do is that, okay, I'm done. Let me just switch over from you and go to another vendor which is giving me a better price or better terms of negotiation or better support, better experience. It can be anything better. But you cannot really switch over in a matter of days. It can take up to months. It can take up to years. I've seen contracts which keep running because people are used to using those tools, and they cannot really get rid of those tools because they are dependent on them, and they're dependent on the data stream coming out of those tools, right? Have you seen that? Do you have tools which are like there forever? Okay, all right, I see nods. It's good for 8 a.m. I'll just take nods. You don't have to say anything. All right, so when we think about all these problems, the concept of full stack observability comes to mind. And as I said, it's a concept, it's not a product. Essentially, full stack observability was something which was defined at Cisco Live potentially 5 years ago, where Liz Santoni, our chief strategy officer at that time and chief experience officer right now, talked about how can we build data from various different sources all together into a single unified pane, so that we can start solving multiple use cases from the source of the same data. Now, that is a pretty big thing to say, because what she's trying to say is, give me one agent which has everything. And in that agent, I should be able to collect all data types, and I should be able to go ahead and solve for every use case on top of it. And that's a tall order. However, in order to make sure it was possible, full stack observability did create, or we started to create this platform which has all these components, as you can see at the bottom. And one of the biggest component over here is being OpenTelemetry native. Now I'll double dive on that in a second. But it was important to see that these are the set of use cases which we are unlocking, starting from AI Ops, where you are taking events from multiple different sources, bringing them together and starting to correlate them, or APM, which is Application Performance Management, where you get signals from your custom applications or commercial off-the-shelf applications and start seeing what exactly is happening inside the application when services are talking to each other. Or infrastructure monitoring, or AIML or LLM monitoring. These are the use cases which were already a part of full stack observability as we are building this particular platform and capabilities on top. But the great news is that when Splunk joins us, and now you have joined us, so thank you, over the past, let's say, 45 days or so, we have rapidly expanded those use cases because Splunk brings in capabilities like log analysis or log analytics like nobody's business, right? Whether you're running logs on-prem or you're running in the cloud, it all comes together with Splunk. Or things like infrastructure monitoring, whether it's AWS, Azure, GCP, or on-prem servers, all of them can be monitored. All of this is still possible without changing what Liz said, which is full stack observability, because of OpenTelemetry. Now you'll say, how is that possible? You're two different companies, two different set of engineers, probably competing a lot of times as well in certain areas. How can, when they join together in a single organization within 30 to 45 days, start saying that all these use cases are already expanded? Now that's a key part of the acquisition as well. Again, I'm not here to talk about acquisition, but jump into OpenTelemetry in a second. But that shows the power of how companies can merge, or they can spin off without impacting their customers or their data strategy because of OpenTelemetry. Now, you'll say, what is OpenTelemetry? For people who have not heard, let's just dive in. So, a few years ago, CNCF, which is the open source body which also released Kubernetes, came up with a project for OpenTelemetry. There were two different projects, OpenSenses and OpenTracing, which were being ran by two different communities. It was decided to kind of merge these communities together in order to build OpenTelemetry. And essentially, the goal over here was to be able to provide APIs and SDKs, or software development kits, which can be used to start instrumenting applications or infrastructure or databases or different services. And all of this is being created by a fully open source community. What basically it means is that the libraries which are getting created are not developed by Cisco or Splunk or AWS or Azure, but people sitting in those organizations, as well as people sitting in organizations like yours who might be consumers of OpenTelemetry and contributing code back to create these collectors, which can then start collecting data from any environment. Now, what it does is it captures traces, metrics, and logs, so all the three data types, and sends that data back to any OpenTelemetry compliant backend. It can be from Cisco plus Splunk, or it can be from other vendors, or it can be other open source backends as well, if you are relying on a fully open source technology in your environment. And of course, I'm not here to say only use Cisco and Splunk, but essentially there are benefits to using one vendor over the other. But if you want to go fully open source with things like Prometheus and Grafana, then obviously that's a choice with OpenTelemetry as well. In fact, more so, if you look at the diagram over here, which explains the architecture, it talks about how you can use the collectors right from the app code by instrumenting applications or using SDKs. You can use something called auto-instrumentation, which I'll talk about in a second. You can also go ahead and get data from infrastructure, whether it's platforms like Kubernetes or other infrastructure such as cloud infrastructure as well. In fact, Microsoft Azure, as well as Google, as well as AWS, have started to contribute heavily in OpenTelemetry as well, and I'll talk about that. Actually, that's my next slide, to talk about contributions and how exactly this community is growing, which is awesome. Now, what happens is that when you look at all these data types being collected, they're forwarded into a single OTel collector. Think of this OTel collector as the aggregator of data which is sitting in your environment and getting data feed from all these different places. And this particular OTel collector has a configuration file which allows you to forward this data stream into any OpenTelemetry compliant backend, which might be open source or a vendor, depending upon what you choose. So it has to be a time series database, a trace database, and a columnar stores in order to store events or log information. It's as simple as that, as compared to all the architectures you might have seen for agents and how they collect and send data out. Now, the exciting thing is this. I mean, when I look at this tells me that, yep, there is something going on in the community which is way different than whatever we have seen in the past. Now, when I say seen in the past, we've seen Kubernetes. Hey, how many of you have seen Kubernetes or used Kubernetes, or your organizations use Kubernetes? Okay, so Kubernetes is the #1 project in CNCF, and obviously it's upstream, it's open source, so everybody contributes to it, and then they pick up a version and then modify it to make it their own if they have to. For example, I'll not name vendors, but anyways, there are multiple vendors out there which do that. If you look at OpenTelemetry, it's the second project right under Kubernetes. So you can start thinking about the popularity of why and how it is gaining popularity. And that can be seen in terms of number of contributors and contributions, which are growing up to be millions now, happening from all different vendors. Now, the contributors are not just from people who have open source software or observability software, but it's also from companies which are using open source for their own benefit and then contributing back to the community as well. Talking about contributions a little bit, you can see the top 10 over the last 3 years. And if you see the #1 contributor is actually independent. There are around 174 over here, if I'm reading it right. Cisco has around 109 contributors, and Splunk around 64, last I pulled out this report. And between Cisco and Splunk, obviously we are the #1 contributor, as you can see. There's Microsoft, there's Amazon, there's Observe, Google, all of them are out there. What does this mean? Now imagine you go to a vendor and buy observability, which is not OpenTelemetry based, might be proprietary in some cases. And now the vendor tells you, okay, great, thank you, and thank you for buying us. This is the set of capabilities which we have. You can monitor X, Y, Z, et cetera, et cetera. I have a customer. We were talking about Wells Fargo yesterday. I don't know whoever attended a deep dive in observability, but Wells Fargo talked about leveraging mainframes. How many of you have mainframes? All right, 1, 2, 3, 4, 5. There are very few players out there who are actually doing mainframe observability. In fact, I can count on fingers. And very quickly, they started monopolizing what they can do with their software, which basically means that as a customer, you're tied down to whatever price points or whatever services at whatever price points they're offering, or to maintain your mainframe systems. And the reality is that if Wells Fargo has to run those billions of transactions they talked about, it'll be similar for others as well, whom no matter what or modern application you have or Kubernetes-based application you have, ultimately the transaction will trace down somewhere to mainframe and come back to your end users. Now, the reason I'm telling you this story is because OpenTelemetry can help here as well. So in this particular case, we started working with MainStore, which is one of our Cisco partners. And instead of us building a solution, they started contributing to OpenTelemetry, and they've opened a project for mainframe observability. What it means is that companies like MainStore, SAP, Broadcom, and customers like Wells Fargo can now start contributing and building collectors which can start collecting data from mainframes and start sending it back to any OpenTelemetry backend. Now that's the power of having a community-based development rather than having development in-house or depending on a vendor 100%. And if you think about it, as you open and start using OpenTelemetry, you get the opportunity to contribute back because it's not a heavy lift to go ahead and code. It's all about knowing what domain, what metrics, what attributes to collect from a given system, and using the OpenTelemetry manifest to start collecting that data, send it to the collector, and push it out to any OTLP backend format, OTLP format backend. And as you do that, you can start being the partner with the OpenTelemetry world itself. So you're not alone. As the number of contributors increase, they start working for you in a way, as compared to you doing all the heavy lift. Now, quickly, a few numbers. As I said earlier, 18,000 plus contributions from Cisco itself, 100 plus contributors, and obviously we have a huge community within Cisco, which talks and works day in, day out on this. More than this slide, I think the next slide talks about capabilities, which is pretty exciting. So from the left, just from an implementation contributions perspective, whether it's web server instrumentation, JMX metrics, container resource detection, test telemetry generator, these are all contributions which have been going on from our developers. Some things which I'm very proud of is basically probabilistic sampling. This is very recent. Now, the problem with any observability or monitoring is the cost. When you start collecting a lot of data, you start paying a lot of money. Either you're paying it for your own infrastructure, if you're running observability, which is self-hosted, or you're paying it to a vendor. Now, probabilistic sampling is a way by which we can start looking at span data. Okay, let me just go into what is span data. Anybody has used spans, traces in the past? Of course, right? So from an application point of view, if you think about end-to-end application services, in order to traverse those services and the flows between them, you can use tracing or distributed tracing. And distributed tracing allows you to tag a particular flow and carry the context forward across till the flow is executed completely. To simplify, you might go to Amazon.com, you log in, that's a flow. That's a code which is executed. Now at that time, the backend code will put a trace ID next to your login, and that will be called a span. That is an individual transaction which has happened. And then you go ahead and search. So you'll hit the inventory service and start searching for, whatever you want to search, like a shirt. And then once the results are there, you might just go ahead and say size. Now you're querying the inventory service for different sizes. And then you're clicking add to cart, checkout, and so on and so forth. Now all these are little interactions of a human with software, and all these are tagged as spans. And a trace header is given to them so that we can stitch all of them together into a single context, which is called a trace. So you might have multiple spans in a trace showing the entire journey of the user. Now, I talked about a very simple transaction. You don't really go in Amazon.com, search for a shirt, add to cart, and send. No, you don't do that. You compare, you go to reviews, then you see the bad review, then you click on a video and see how the video looks like where the person is wearing the shirt. And then you take that price and compare it with somewhere else. Imagine the number of spans which are generated when you do a simple transaction like that. Now, that can quickly add up because these are all real-time insights which we are collecting, or any OpenTelemetry or any proprietary vendor would want to collect as well. Because what you want to see is, as a provider of Amazon.com or any of these retail services, is where is the user stuck? When they click on add to cart, is the spinner just going and nothing happening? And if that's the case, you want to go ahead and capture that information so that you can fix it in your code. And that's why you collect all these spans. With probabilistic sampling, we are able to use either head-based or tail-based sample, where we are able to go ahead and define what kind of spans we should collect and what we should not, right? And in case of head-based sampling, you can simply say, only collect 95% of the spans or 50% of the spans. Leave everything out. Now, that's not a good thing, because that means that you might miss certain critical spans or transactions which are important for you to measure for various different purposes, for troubleshooting. Or some people also use something called span attributes to calculate values. For example, in an order cart, or let's say in a cart, you can see an order value of $100, but nobody submitted and did a payment checkout, which basically means you've left $100 of revenue out and nobody went through that process. Why? You want to know that. And you can actually calculate these numbers as custom metrics and start seeing how much revenue you've left on the table, or how much order values have gone in, and so on and so forth. Now, these span attributes are critical, and you don't want to sample them out, because if you do, you will not know the right dollar value. Very simple, right? And hence comes probabilistic sampling, where you can start providing inputs, and we can use heuristics to figure out what are the spans which we need to drop, which are noise, versus what is signal which we can collect, and start making sure that you have full fidelity data in terms of accuracy, and at the same time, you are able to control the cost of collecting all this data. So that's a huge thing, because now, no matter what the vendor is, if they are supporting OpenTelemetry, and if you are a consumer of OpenTelemetry, you are benefited from this. And you're able to save your cost with any backend platform selling observability to you. Now, that's another example. Obviously, as I talk over here today, I'm more OpenTelemetry than Cisco, because I want to make sure that we can promote this technology across the board, across all of you and others who've joined us, so that we can really make observability simpler and easier and more economical as well. This is another favorite example. So this was a customer, a big, large retail store in the United States. Hint, hint, makes clothes for children's. So talking to them, they said that, hey, we have been using your proprietary app dynamic software, which has an agent which provides us insight into our Java applications. And the kind of metrics we get from there is next to none. I mean, it's not possible for us to not have that kind of visibility. But we want to switch to OpenTelemetry. How can you help? So over the past, so all those contributions you saw from Cisco, so over the past 3 years, what we've been doing is taking all the proprietary work we've done in our past software, on the software which we have been running for 10 years, and taking all that intelligence and contributing back to OpenTelemetry. And JMX Insights is an example, so that we can start collecting those signals and start ingesting into any OpenTelemetry platform. So really here is an example of a customer coming and saying, I want to change the way I collect data. I want the same accuracy, but I want it in an open source format. And guess what? We delivered it, and we'll continue to add more. In fact, it's not just us, it's also Splunk. In fact, if I look at the numbers, they're crazy. Splunk is number 1 in terms of contributing to open source or OpenTelemetry. As I said earlier, with Cisco and Splunk, now we have more than 240K contributions made to OpenTelemetry. Again, that is still lesser than the bigger overall community, which are unnamed or non-named people. And I hope that remains that way, because obviously the community is way bigger than any organization in this case. Now, some of the benefits which I think I spoke about as we went through, but I do want to recall some of those as well for you to remember. And this might be a good slide for you to kind of go ahead and justify and start talking about OpenTelemetry in your environments. Don't click a picture right now. I'll build it up for you first. All right. So obviously, over here, you took a look at what exactly are the components of an OTel collector. And where you can have receivers and exporters. And of course, everything over here is open source. So I'm not saying buy this tool or the other. But yeah, if you just want everything 100% open source, then this picture is enough. You can actually start collecting data, start processing it, and start sending it to a backend and start consuming it in an open source format. Obviously, you would not do that in certain cases where you want a larger scale, or you want enterprise readiness, or you want support, and so on and so forth. That's where you choose a vendor which can support OpenTelemetry. But if you do that, you definitely avoid vendor lock-in. So the problem of having a big bill and not being able to switch is no longer true if you are on OpenTelemetry, because you can literally have a collector and point the data to a different source right within a configuration change of 2 lines. And once you do that, the same data set, which was going to one tool, is now going to the other tool from the same quote-unquote agent, collector, whatever you want to call it. And you're not answerable or relying on somebody to do a migration project with professional services over months to get you moving away from one tool to another. And guess what? It's not just the use case of CPU, memory, or applications or infrastructure. It's a use case of networking. Thousand Eyes supports OpenTelemetry, for instance. Is the use case of security. A bunch of security vendors support OpenTelemetry. So now you're really simplifying the collection, processing, and lifecycle management of data in your environments by choosing this strategy. The second is data flexibility. So as I said earlier, it's not just about what is available. It's also about what you can create for your own environment. There's a large I would say, era of support for custom metrics, which means that now you can go ahead and create your own metrics and push that with your OpenTelemetry package or payload into the collector. And you can use Prometheus or any other choice of tool in order to start visualizing those metrics. So when I say custom metrics, imagine, I was just talking a second ago about collecting revenue from attributes of spans. That's a custom metric in a way. So you can similarly collect what you want. For instance, if you have an OpenTelemetry feed of how many people are in this room through a camera sensor, you can actually take that attribute, or through the check-in in the room, that's easier, not through a camera sensor. Then you can actually take that attribute and then calculate that and show it on our dashboard if you want to. So think of any of that use cases where you want to show visibility or have visibility into a given metric, you can do that with OpenTelemetry. Easy to set up. Now this is a case where we're talking about instrumenting once and forgetting it. Obviously, it is required to upgrade the collector as new collector or new code is coming in. But since this is all on GitHub, you can fully automate the process. You don't have to go to a vendor's website, download, and blah, blah, blah. No, you can basically have GitHub credentials, implement this through your CI/CD pipelines, make sure that everything is automated and you're able to push code just like you'll do for red and blue releases. So that you're stable in terms of what you're collecting. Operate at scale. Again, I gave you examples where a customer moved 100% to AWS, and they are busy customers. They were generating 37,000 spans in some of the traces, which is unheard of. I mean, I was shocked. But I realized that on their website, when you go ahead and look for a hotel, it does real-time rate inquiry across all different hotels and chains they support. When I say real-time, a lot of these solutions have cash pricing, which not be exactly the same, and that's why you'll see a different price when you go to the hotel website versus a broker engine. But these guys their unique differentiator is that they do everything real-time, and they have adopted OpenTelemetry 100% and made sure that everything is running at scale. The beauty is that the collector itself can run on a bare metal VM, or it can run on top of Kubernetes. Now, what does that mean is you can actually go ahead and scale collection based on your requirements. So let's say if your business is busy 9 to 5 and you will have more spans or more metrics during that time, then you can have an auto-scaled Kubernetes cluster, which will automatically deploy new pods to have scale-out collector capability and capacity. And all your data is coming into the same stream. As soon as you're done, or it's 6 p.m. and your capacity goes down, you can just scale down the cluster automatically. So now this entire process of being flexible on collection of data is also pretty nice because it's all based on Kubernetes and latest stuff. So the lifecycle management becomes extremely simpler, even if you're operating at scale. I think I talked enough about the community. I am now hoping you all are a part of OpenTelemetry community as well. Please, I have a call to action, but please go sign in and make sure that you are at least starting to get engaged and starting to learn about what OpenTelemetry does for the domain you belong to. It's not necessary to be applications or infrastructure. It can be network, and in some cases, mainframes, as we heard, right? Okay, let's just look at 4 quick points, and then we'll jump into the latest innovations. So, as I mentioned earlier, spans, I think it's the heart of applications, or especially modern and traditional applications. And today, they're generally available all languages with OpenTelemetry. So whether you're using .NET, Java, Python, Go, Ruby, I don't know, 20 languages, and they keep adding every day, so that's the good news. No matter what stack you use, whether it's custom applications or commercial off-the-shelf applications, or applications like Salesforce or Adobe, you will see distributions for OpenTelemetry for them as well. In fact, we are working with large customers along with Salesforce, where they're using their Salesforce backend or Salesforce client for their vendors to interact with this customer itself. So let's say if I'm a vendor-to-vendor relationship and I want to order something from your site, then I'm coming through Salesforce. And that Salesforce instance creates a trace ID, which we track back from the browser of the user down to the front-end application, down to the back-end application, and then the infrastructure. So they can see a single transaction going right from where the vendor came in, they did the entire thing, or they failed, whatever happened, but they're able to trace it down completely end-to-end. So that's where you can start mixing your custom applications with commercial SaaS applications and start having that visibility as well on your workflows. The second is infrastructure metrics. Of course, in the order, it came second as well. So this is kind of prioritized slide. And infrastructure metrics is not just focused on applications or custom metrics. In fact, I have a slide which will talk about what are the new innovations which we have done in databases, in messaging services, and so on and so forth, and how OpenTelemetry supports those as well. Logs, there was a long wait before logs became generally available. Now, I'm talking about these terms. Let me just kind of give you a quick overview as well. So when you go to OpenTelemetry.io on your cell phones or later on your laptops, as you look at the left-hand side in the documentation, it talks about different stages of maturity for different technologies or different signals which you're collecting. Logs, I believe it's been 1.5 years or 1 year, close to 1 year, where it's been moved to GA or production. It basically means that it's stable, you can go ahead and get it. And that's how the open source world works. It tells you whether it's stable or not, you should use it or not, in production or not. So you can definitely try some of the newer technology, but as you adopt that in your enterprises, make sure that it's a stable version. Because now the entire community as well as the vendors are ready to support it because they've made sure it's gone through all the tests for you. So logs is generally supported, and obviously with Splunk, it supports OpenTelemetry and supports logs. In fact, I believe they had a big role to play in making logs a part of production with OpenTelemetry. And the last thing is profiles. So this is new, still being designed. In fact, I've seen versions of profiles which is being used. So code profiling is a way by going ahead and understanding the problems in your code even before shipping it out in some cases, or running online code profiling to understand what's happening in your transactions and measuring that as data is as code is being ran in the backend. Now, most of the developers need this use case, and hence the community is working really hard to make sure profiles are available to ensure that you can debug even before shipping out code into production. Let me quickly talk a little bit about the latest innovations, and then we'll jump into any kind of Q&A. Or I'll also have Bill, if you want to add something, we'd love to hear you as well on this. Cool. So this is one of the latest one. I'm calling it GDI, or it's also called as getting data in some cases. But I think both Cisco and Splunk have been working heavily on this. And in fact, AWS has been working heavily on this as well, apart from other open source contributors. Now, I talked about agent and how simple it is to have a single agent, but the reality is you still have to manage it. So I'll be lying if it says that everything is done now, go home, enjoy. No, you still have agents, you still have collectors, and you need to manage them. And in a lot of cases, you either manage them through your CI/CD pipelines to do lifecycle management, or OpenTelemetry has created a project called OpenTelemetry Agent Management Platform, which is called OpAMP. And OpAMP is being used in order to create agent lifecycle management, which means that you can have a single console from where you can deploy, you can upgrade, you can uninstall, you can monitor, and so on and so forth. Now, this really changes the game as well, because now if you're a small shop or a medium shop who's not automating the process by using CI/CD, then you can really use the single console to go ahead and manage and operate all your agents, which might be running on VMs, might be running on Kubernetes, and so on and so forth. And most importantly, you have alerts and alarms when we are not collecting data. Because sometimes that's a problem, that if you're not collecting data, no matter whether it's OpenTelemetry or any other technology, if it's not running, you need to know. And that's what is one of the latest enhancement which has been done. The second, and this is my favorite, is called auto-instrumentation, especially for custom applications. Again, this has been out there for some time. This slide talks about some of the latest innovations which have been added there. But the great news is that if you look at traditional way of monitoring applications, you might have to go to your developer and say, hey, why don't you go ahead and, when you're creating this custom application using Java, Python, Go, why don't you go ahead and emit certain metrics which I want to monitor as an SRE or an app ops guy, or even the developer might want to emit those metrics or those logs or those events. And that is code. So they have to go write code, redeploy application, compile it, and redeploy it in production. Now, that's a pain point, because if you are looking for a new metric, as operations or even as a developer, you need to wait for the next release cycle, and you need to instrument the code. And obviously, touching code every day to start adding things like observability is a pain point, so people don't want to do it. So when OpenTelemetry started, people had to manually instrument these libraries or SDKs in order to get this data out of the system. And the community kind of rallied around that and said, this is a big adoption blocker or a problem, because you cannot have or expect every developer to go ahead and do this change, because they have other things to do. So to make it easier, auto-instrumentation came into picture, where you just add 2 lines of code in your overall system or application, and then pull it from a Git library that any pull requests or any new changes which are happening are automatically pulled in the next deployment cycle. And that ensures that the developer does not have to instrument the application themselves, but it's auto-instrumented, and any kind of signal which is defined by OpenTelemetry, whether it's metrics, events, logs, or spans, is automatically pulled from that particular application. So what the slide is talking about is we have Java support, Node.js, .NET, and so on and so forth. Python support is coming soon. In fact, it's a little dated. I was reading, and this is when the problem of creating a slide is the community is faster than slideware. So I was checking this morning while you guys were coming in, and I see Python is already, they've already started supporting custom applications on Python as well. Yeah, sure, please. And be loud.
Oh, am I loud enough? Can you hear me? All right. So, Sonny covered a lot about auto instrumentation. Obviously, we believe it's pretty important to add manual instrumentation as well to get value. Automatic discovery and configuration. Also, when you run the collector will detect a Java application and will automatically kick off that auto instrumentation. Same thing for other languages. The configuration part is that we can discover, for example, MySQL is running on a system. And so rather than having to configure it manually, for MySQL, you may need to provide credentials. But the point is that it will automatically detect this, report it so that you can then configure it. And for some things that don't require any credentials, it'll just start picking it up and sending the metrics. So really powerful capability.
Thank you. And I was standing near you. I love you, but also because of the mic. All right. Thank you so much. And yeah, as I said, I have that slide, so you can speak to that now. But essentially, as Bill was just talking about, automatically discovering databases, messaging queues. I think you had this question yesterday from one of the sessions, so yes, and it's also doing query-level profiling. So I'm not doing a demo of Splunk or Cisco products because this is purely an OpenTelemetry session. I wanted to, but in reality, if you go to one of our products and start looking at how this OpenTelemetry feed is being used and kind of show you insight, it's pretty powerful. Some of these dashboards and screens are from Splunk Observability. So that's what you see right now. But Bill talked about the slide, so I will quickly jump on to the last one. No, you're good. So let's just look at a few key takeaways, and hopefully this will give you some insights when you go back to kind of read about OpenTelemetry and learn more and contribute more. So obviously, observability cannot be bought. I like this. A lot of vendors, a lot of salespeople, let me just put it that way, will come and say, you can buy, we have everything, and it's all ready. But the problem is if you don't design, then you're getting logged in, or you're not making sure that your investments are in the right place. So please design your observability, and for that, you need to choose something which is open source, right? And what I'm recommending, what Bill recommended as well, is go with OpenTelemetry, because the number of contributions which are happening, I'm pretty sure it'll go beyond Kubernetes pretty soon with the number of changes which are seen. And obviously, you can get started with OpenTelemetry today. You don't have to wait. Join the community. At least start reading about it. It'll help build your resume as well, because I'm pretty sure this is the skill of the future. And the more you know about it, the better it is for your careers as well. I happen to write a blog post which kind of goes more into details. It is technical plus a business-centric blog post as well, so you can scan that QR code or go to my blog, which is sunnydua.com, and that's the latest post from 2nd May. And you can share it with your bigger bosses as well, so that they can understand the strategic parts behind OpenTelemetry. And last but not the least, if you want to experience this, we have a free trial for Splunk Observability Cloud. It's a 15 days free trial, if I'm not mistaken. You can just go and sign up, and it is available to you immediately. And then it takes you through all the step-by-step instructions on how you can instrument an app or a Kubernetes cluster or connect to AWS, Azure, GCP, any of your accounts, and start bringing in telemetry data, either based on OpenTelemetry or in some cases proprietary data as well if you're collecting from CloudWatch, for example. And then show you the entire end-to-end image of your application flows, whether it's Java, Python, Go, or even if you're using any of the infrastructure collectors which are OpenTelemetry based, and you can start collecting data on infrastructure as well. So that's the trial if you want to go ahead and do that. All right, perfect. That was the session. So I think we covered 45 minutes worth of content. I'm happy to answer any questions. I have Bill as well, so we can take any questions if you have any questions at this time. Yes, sir. So the question was that does OpenTelemetry works with Nexus 5000? Nexus 9000, streaming, okay. I don't know the answer to that, I'm sorry. So we do have something called a Cisco telemetry broker for metrics, and that is centralized on OpenTelemetry. And what we're doing is we're working with the entire Cisco ecosystem of different product managers, products, and developers to start adding OpenTelemetry stream into their product line. For network, though, I can tell you the goal is to move more towards eBPF and then convert that eBPF signal into OpenTelemetry. Now, eBPF is Enhanced Berkeley Packet Filter, and that is something which was developed by a company called Isovalent. And Cisco bought that company, but it's still an open source technology, so a lot of vendors out there use eBPF, which can get you kernel-level metrics from any Linux kernel. And now you're talking about packets or CPU transactions which are happening at the microcode level, and eBPF is able to collect and capture that. And that's what we are using or planning to use for all our Cisco devices. So eBPF is a term, a readout, but what you can do with OpenTelemetry is, going back to my topic, is you can convert any signal type. It can be JSON, it can be API response, into OTLP format. You are a vendor or a partner or an open source community developer, and that OTLP format then be pushed into a backend like Splunk Observability Cloud. But yeah, that's the way to go about eBPF. Yes, sir.
Yeah, with this OpenTelemetry, it just opens up the world to a lot of ocean or waters, right? So signals. So the community that you said, the community post that you said, would help us with what are the signals that we want to use as part of our observability journey versus the signals. I know we can custom create signals, but always custom means I have some things, I want to create unicorns or rainbows, but that doesn't work well in my observability landscape, right? So are there any documentations and directions on what signals, how to use them? This is what we are going to get from this collector and all those.
Absolutely, great question. I'll add, and then Bill, you can feel free to add as well. So Deva asked a question. First of all, I like the analogy of moving from seas to oceans. So yes, when you go to OpenTelemetry, the world opens up, and you're now open to a lot of different collectors which you might be wishing for or were not even aware of that exist. So the good news is, as I mentioned earlier, the documentation is pretty solid. So if you go to opentelemetry.io, on the left-hand side, you can see everything starting from the architecture down to who are the contributors, who are in the steering committee, and there are a lot of people from Cisco in the steering committee as well. But all of these people, including Morgan, who couldn't be here, unfortunately, he's sick. He's a co-founder of OpenTelemetry. He never wanted to put a name of any vendor on our slides, because that's how the community works. They're not relying on vendors, they're relying on humans and individuals. So you will see amazing help as soon as you go to the community and say, hey, I want to monitor this. You will either find a project, which is already there. It might be in a different stage, production, non-production, or somebody will come and say, let's start a project, let's get going. So the great news is that as soon as the project goes into production phases, any vendor who is supporting OpenTelemetry has to support what you are using as a collector, which is open source as well as has been certified by the community. A lot of times, vendors also create their own distribution, right? They do it for a couple of reasons. One is, obviously, they want to innovate even faster than the community, or they want to take things proprietary or at least add some magic sauce on top of that, which is proprietary to them. Could be because of their backends. They want to make sure it works with their backends in a way which might not work in a generic format. So they change that as well. So again, I would not say that do not go with a vendor distribution of OpenTelemetry. In fact, if you look at AWS, they have launched ADOT, which is AWS open source distribution, or AWS OpenTelemetry distribution. And what they're doing is pretty cool, because they're saying, hey, if you're running on AWS only, your applications are here, your infrastructure is here, I can start instrumenting that by default for you using ADOT and start sending those signals to CloudWatch or X-Ray, and you can start observing them or bringing them into any of your OpenTelemetry backends. So I see a future where with things like OpenTelemetry and standardization, you might not even have to think about putting in an agent or a collector. That would be done by default by a SaaS service or by an infrastructure as a service provider for you. So that's where it's headed. In my mind, again, this is my personal commentary. I don't want the recording to go to the community and they start blaming me for something which is not there. But yeah, that's where it's headed. Yep. Yes, please.
So the first thing I want to say is you can contribute in many different ways with OpenTelemetry. It can be code, but it can be adding issues, joining a SIG in discussion. So lots of ways to contribute. We talked a little bit about getting data in, and you may have certain things. Just things to be aware of when you look at GitHub. When you look at the collector, for example, collector has like a base project. Then there's a contrib project, which has all of the receivers and contributions from anywhere. So receivers are how data goes into the collector. Then you have processors that process the data, exporters send them out. So if you look at the contrib project for the collector, you'll see all the contributions of things that could go into a collector. And then you can have your own distribution that Sunny just talked about, which is, this is a more opinionated way of putting the collector together. For example, Splunk has a distribution that includes how to send data to Splunk Observability Cloud. Honeycomb would probably not include our exporters. But the point is, it's all operating the same way. So whether you use Honeycomb or Splunk, it's still OpenTelemetry. If you edit your code and add in manual instrumentation, you move from Splunk to Honeycomb, your investment stays there. So hopefully that just gives you a few keywords to keep in mind.
Remember, absolutely. Yeah. No, thank you.
Yeah.
Yep. Cool. Any other questions? All right, so if you don't have questions, take out your cell phones, find the survey, and fill it out. Please give us feedback on how we can do better next time, so that we can come back and do better next time. And hopefully this was a good session for you. You can continue to connect with me. My email address is up there if you wish to. And, or go to Cisco Live On Demand, where you will see these sessions recorded. So if you want to go back, revise, you will see the session, listen to it, spread the knowledge, and increase the community is the call. Thank you so much. Thank you for coming here. Appreciate it.